Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, IIT-Jam exam, Jest Tifr, and other exams related to physical science. And also I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my live lectures which are free of charges, and are going to help you to crack the examinations related to physical science. Okay, so this is the lecture number 9 of quantum mechanics CSIR net PYQs. Okay, so I'm going to start now. So question number 1 is, a particle is in is in the ground state particle is in the ground state of an infinite square well potential potential given by Vx equal to 0 for x is between minus a to plus a. Okay, if it is the case, then Vx is 0 or infinite otherwise. The probability to find the particle the probability to find the particle in the interval between minus a by 2 and plus a by 2 is, options are 1 by 2, option B is 1 by 2 plus 1 by pi, option C is 1 by 2 minus 1 by pi, and option D is 1 by pi. Okay, this is the question. Okay, solution is, a particle what is given? A particle is in the ground state of an infinite square well potential. So particle is in ground state of infinite square well potential, and potential is given by this. Okay, so this question is already done. Yeah, it's not done. Okay. Okay, so Vx is 0 and infinite for 0 for if x is between minus a to plus a and infinite otherwise. The probability of finding particle in the interval between minus a by 2 and a by 2 plus a by 2 you need to find out. Okay, you need to find out the probability. Okay, so here we can see it's a symmetric potential is symmetric. Okay, symmetric potential. So because it's a symmetric potential like this, minus a, and this is 0. Okay, particle in this box, infinite box. Okay, so it's a symmetric potential, and a is going to be L is going to be 2a, right? L is going length is length is going to be 2a, right? Width of the potential box. So this is in 1D, right? This will be x equal to like this. So in that case, so we know then wave function is going to be wave function psi is going to be normalized wave function psi is going to be 2 upon 2a 2 upon 2a cos pi x upon a, right? Pi x upon 2a, right? This is going to be the normalized wave function for this particle which is in this infinite potential box. Okay, well, right? So this is the one, and so now we have to find probability of finding particle, and we know that, right? We know it's going to be psi mod psi square or psi or it is going to be psi, right? And this is the value of psi. So here we'll find it. So probability is going to be very simple question, going to be integration minus a by 2 to a, because between this we need to find out minus a by 2 and between minus a by 2 and a by 2, and this is going to be so psi star psi dx, right? So this is the psi, and psi star is also will be the same because there is, or we can write it like this, 1 upon root a cos pi x upon 2a, because 2 will get cancelled. Okay, so here so we can write integration minus a by 2 to plus a by 2, and this is going to be 1 upon a, because 1 upon root 2, 1 upon root a and 1 upon root a is going to be 1 upon a, and this is going to be cos square pi x upon 2a, cos square pi x upon 2a. Now it's simple integration, you need to integrate it, right? So it is going to be 1 upon a, and we'll convert it like we know, cos 2x equal to 2 cos square x minus 1, right? From this trigonometric identity or expression will find the value of cos square, right? So this is going to be 1 plus integration minus a by 2 to plus a by 2. Okay, and this is going to be 1 plus cos 2 pi x upon 2a dx, right? Now we'll solve it. So this is going to be simple integration, right? So this is going to be 1 upon 2a is also here, 1 upon 2, right? So 1 upon 2a will be common, going to be, we'll integrate it. This is x plus a upon pi sine pi x upon a pi x upon a sine pi x upon a pi x upon 2a okay. So 2 will get cancelled, right? So it is pi x upon 2 pi x upon 2a, 2 will get cancelled. This one, and integration, and limit is going to be minus a by 2 to plus a by 2, okay. So then by solving further, it is going to be 1 upon 2a into a by 2 plus a by 2, we have put the limit, okay, plus a upon pi, very simple integration, 1 plus 1, right. So this is going to be 1 upon 2a will be a plus 2a upon pi, right. So this is going to be 1 by 2 plus 1 upon pi. Okay, 1 upon 2 plus 1 upon 5. So this is the answer. Which option is matching? Let's see. Option number B is matching. 1 upon 2 plus 1 upon 5. 1 upon 2 plus 1 upon 5. Okay, very good question and simple as well. Next question. Next question is question number 2. This is a good question actually. So this is expectation value of the expectation value of the x component of expected value of the x component of the x component of the orbital angular momentum Lx in the state psi equal to 1 upon 5 3 psi 2 1 minus 1 plus root 5 psi 210 minus root 11 psi 21211. Okay, this is the wave function which is given, where psi and lm are the eigenfunctions in usual notation. Is okay. is options are option A minus h cut root 10 minus h cut root 10 upon 25 into root 11 minus 3. Option B is 5 3 psi 2 1 minus 1 plus root 5 psi 1 2 psi 1 0 minus root 11 psi 2 1 1. Okay, so expectation value of this you need to find out. So you need to find out Lx. How to find out? Okay, Lx you need to find out. Okay, so we know value of Lx is L plus upon L minus by 2. This is the formula we know. Okay, Lx value is L plus minus L minus by 2. So in this similar fashion, Lx is going to be expectation value of Lx is going to be expectation value of L plus expectation value of L minus by 2, right? So we'll find out value of L plus and L minus separately, and then we'll put value in equation 1. We'll get the required answer. Okay, so now here we know the formula, right? L plus L m. Okay, L plus Lm. This value is going to be root L into L plus 1. Okay, L into L plus 1 minus m into m plus 1 h cut. Okay, very simple. And then this is because this is L plus, right? So state is going to be L into m plus 1. State will get increased. Okay, L into m plus 1. Very important formula. Similarly, L minus, if we operate L minus with this Lm, right, function, so this is going to be very simple. L into L plus 1, this is L plus, so this is going to m into m plus 1, minus this is L minus, so it is going to be m into m minus 1 h cut, and this is going to be L into L m minus 1 because it is a minus, right? Minus 1. This is these are very important formula, guys. Okay, very important formulas. You need to note down and memorize it, and you can memorize it by practicing questions. Okay, using those formulas. Okay, now very simple. Now you need to find out the Lx. So Lx is going to be, so here if you do like this, L plus psi. If you are going to L plus psi, you have operate psi with L plus. Okay, psi is this one. Okay, so it is going to be, I will put this formula 1 plus 1, right? So this is going to be L psi is going to be 1 upon 5 L into L plus 1, right? 1, L is there, 1, right? L is 1 and m is minus 1, so it is L into 1 into 1 plus 1, this is 2, minus m into, this is minus 1 minus 1, and this minus 1 plus 1, this is going to be 0, 2 h cut is going to be, right? So this is going to be, L plus is going to be 1 by 5 3 using this formula, okay, this formula. Okay, so this is going to be 3 root 2 h cut, it will be 2 h cut. Okay, and minus 1 upon 25, sorry, 1 2 h cut psi 1 0. Okay, psi 1 0 psi 2 1 0 psi 2 1 0 plus 5 root 5 is there. Okay, root 2 h cut again it is going to be, and psi 2 1 2 1 1. Okay, by putting formulas here. Yeah, and plus this one. And next, so then this is going to be psi, or we can say it like this, L plus, expectation value of L plus is going to be psi L plus psi, right? And this is psi L plus psi, and this is the psi. So if you put the, if you operate it, so it is going to be 1 upon 25 into 3 root 10 h cut root 2 n h cut. Okay, minus 1 upon 25 root 110 h cut. Okay, so this value is going to be 1 upon 25 root 10 3 minus root 11 h cut. Okay, this one. Okay, now similarly we'll find L minus. Okay, L minus expectation value, and this value is going to be, this value is going to be 1 upon 25 1 upon 25 3 root 10 root 11. Good. Okay, so this is 3 h cut 1 upon 25 root 10. Okay, so now L is going to be, expectation value of Lx is going to be, we'll put this in equation 1, this one, right? Equation 1 here. So it is going to be L plus L minus by 2, and we'll put the value. After putting value, it is going to be 1 by 25 3 root 10 h cut minus 1 upon 25 root 10 root 11 h cut. Okay, so this is going to be minus h cut root 10 upon 25 root 11 minus 3. Okay, so this is the answer, guys. So very simple. It's a lengthy calculation actually. So we have used this formula, right, for this, and we have found this L plus 1, right, and then we have find L plus 1 operating this with this one side, right. In similar way, we have found L minus, and then we put value here. So this is going to be a lengthy calculation, guys. So you need to practice it and revise it and use this formula. This formula is very important. Okay, so if it is L plus, then L is going to be same, but M, there is a increase of 1 in M. Okay, similarly in L minus, L into M minus 1 will get decreased. Okay, similarly here, if it is plus M plus, it is minus M minus. Okay, so this is the one. Okay, this is the question number 2. Next question we are going to solve.